This is AAT section 3.6, Graphing and Connections. Now hopefully we've been talking all the way through this unit about the connection between zeros and roots and x-intercepts and end behavior and direction, and how it's all whole big picture is to help you graph these polynomials. So let's look at something that is cubic, for instance. What do we know about it? First of all, if we need to find the zeros, we need to find the zeros by either grouping, or we could use the rational root theorem and find those possible rational roots and synthetically divide until something works. Well, let's just talk about, can we group it? Well, I think we can. It looks to me like we can. If I group the x cubed plus 3x squared together, and I'm going to put a plus, a negative x minus 3 together. Remember, don't pull that negative out because you'd have to change all the signs. So I'm always making a plus minus when you're separating them. Then the GCF here is x, and we're left with x plus 3. And the GCF here is a negative 1, plus. And we're left with the x plus 3. And then we do the opposite of distributing. So it's x plus 3 is multiplied by both of these things. We pull out that x plus 3, and we're left with the x minus 1. And those are my two factors. Now, excuse me, this was an x squared we pulled out. Whoops. Mistake there. We pulled out an x squared from the beginning. So this would be x squared minus 1 that would be left. Should multiply back to be a cube, so I knew that I did something wrong. So x squared minus 1 is still a difference of perfect squares, so I can go further. X plus 3, and I have x minus 1 and x plus 1. These all have a multiplicity, meaning each factor occurs only once. So if that is an odd number, an odd multiplicity, it passes through the x-axis there, not just bounces off, just hits it and bounces off. So we already know so much about this one. Don't forget our end behavior. We know if something's cubic, it's an odd degree, and it starts with a positive leading coefficient because it's 1 up front, that it's going to start down and end up. We also know about that cubic that the number of turning points are n minus 1, which would be 3 minus 1 cubic is 2, at most 2 maxes or minimums, global or local maximums or minimums. So we talked before about, since this is cubic, it's either going to have 1, 2, 3 directions at most with 1 max and 1 min, or subtract by 2 and have just 1 direction and no maximums and mins like that. But we know it starts down, ends up. So we already know so much about this. The roots are negative 1, 1, and negative 3 coming from each of those factors setting equal to 0. I know my y-intercept. Remember, my y-intercept is just where x equals 0. It's so easy to find. 0, 0, 0 would be negative 3. So my x-intercept is always, my y-intercept is always just where x equals 0. So let's just write it that way, and we would be left with a negative 3. So another thing, we're trying to get as much as we can to help us graph it. Our factors were x plus 1, x minus 1, and x plus 3, which gave us our x-intercepts. Our negative 1, 0, write them with a 0 for the y, 1, 0, and negative 3, 0. And our end behavior, remember, starts down and ends up. And if we're starting down and ending up, as x gets smaller, which means x is going left, y is going down to negative infinity. And as x gets bigger or goes right to positive infinity, y is going up. That's how we write that in behavior. So look at all the stuff we have as the graph to graph it. Also, we know there's two, at most, one max and one min. Okay, so our x-intercepts are -1, 1, and -3. -3. Our y-intercept is -3, 1, 2, 3, so we put that in. We know it starts down and ends up, so I'm just going to swing a nice little curve in there. I don't know how low it goes exactly or how high, but I know it looks something like that. And we could find exactly where those points were, and we could always plug in to get more points. We know so much already. Okay, so find the zeros of 3x to the third minus 10x squared minus 23x minus 10. Okay, so this one, looking at it, I can tell I'm not going to be able to group this factor by grouping, so I need my possible rational roots, which are the factors of 10 plus or minus 10, 5, 2, and 1 made into fractions over the factors of 3, which is plus or minus 3 and 1. So that would be 10 over 1, and this is a big plus or minus out in front, 10 over 3, 5 over 1, and 5 over 3, 2 over 1, and 2 over 3, and 1 over 1, and 1 over 3. So now I just start synthetically dividing till I find something that works. I can already tell 1 is not going to work. You can always tell 1 by just combining those coefficients. 3 minus 10 is -7. Minus 23, I can tell I'm not going to get to 0. So I'm going to start with -1. I'm going to synthetically divide by 3, -10, -23, and -10. Drop that 3. That's -1 times 3 is -3, -13. That'd be 13, -10. 10, yay, I'm going to get 0 as my remainder. So -1 is my first 0. So what do we do now? Well, we've depressed the equation. It's now 3x squared minus 13x minus 10. So we can either use quadratic formula, or I think that one might factor. Let's see, 3x and x. If I do 3 and 1 for the first, let's see, 5 and 2, let's see, 2 and 5 for the second would give us 15 and 2. I need a -13 in the middle. That means I need a -13 here, -5 there. I think that'll work. So 3x plus 2 and 1x minus 5. So my roots are, that would give me what, a -2/3 and a 5. The y-intercept, remember how to find the y-intercept. I put in 0 for x. I just get -10 for the y-intercept. So 0 and -10, very easy. My factors were 3x plus 2, x minus 5, and don't forget x plus 1. Sometimes people forget that first one we pulled out. So the x-intercepts are -1, 0. Put it in an ordered pair, 5, 0, and -3, 0. So you know you're graphing it right. In behavior, this one again is an odd degree, the positive leading coefficient. So it starts down and ends up. As x goes left, y goes down. As x goes right, y goes up. Right, so let's plot what we know. A y-intercept of -10, I know it's all the way down here. My x-intercept is -1, 0, negative, oh, I put 3 halves instead of 2/3, that should be 2/3. -2/3, which is, you know, in there somewhere. Doesn't have to be perfect. And 5, 1, 2, 3, 4, 5, 0. So we're going to squeeze it in here. Starts down, and then it's going to come over and grab that 5. 5. Something like that. Might go a little lower, might go higher, we're not sure. Oh, actually it does go lower. I gotta grab that 10. So it's gotta do more like that. Don't forget that y-intercept. That y-intercept just helps us by giving us an extra point. So we know it does go a lot lower than I had drawn it originally. Okay, so now you try this next problem and then come back and check. Because I'm losing my voice.